Hey everybody, it's Mr. Oaks. So we're going to finish up factoring polynomials with factoring polynomials completely. So this basically comes down to we're not always going to be doing one factoring method at a time because we can have polynomials that actually have multiple steps in factoring it. And whenever you factor, you have to factor completely. You want to basically break it up into all the pieces that would multiply together to come back to the original polynomial. So, some questions you want to ask yourself as you are going through and trying to factor completely. The first one is there a GCF? Is there a greatest common factor? That's because that's the easiest one, that's like the lowest level factoring you could do. Basically, is there a number or a variable that all the terms within the polynomial have in common? And as long as you pull out that greatest common factor, what you have left over now is either going to be one of two things. It's either going to be well, I shouldn't say one of two things, but it will make things easier. Like if you have to keep factoring, you can then ask the next question. Is the polynomial a difference of two squares? So you pulled out the greatest common factor, you know it's the greatest common factor, and you look and you see what you have left over. Does it have subtraction? Is there only two terms? And are those two terms both perfect squares? So if you have that, well, then you can do a difference of two squares. If the answer to that is no, then you're going to move and you know you're going to be doing some form of trinomial factoring. That's all we're going up to at this point. There are other polynomials, you go to the third power or fourth power, things like that, and have more and more terms. But we're only going to deal with up to trinomials. So the third question is the leading coefficient of the trinomial equal to 1? And actually, there's a reason why I didn't write trinomial here, because even if it is a difference of two squares, you have to look at that leading coefficient and say, well, is it just going to be nice and easy and I have just whatever that variable is in the front, and if there's an exponent I can put that on, or do I have to worry about that first number? Is that a perfect square? So those are the questions you want to ask. Is there a greatest common factor? Yes or no. Is the polynomial a difference of two squares? Yes or no. Is the leading coefficient equal to 1? And from there, you should be able to figure out which method you're going to use in order to factor your polynomial completely. So I have 6 examples that we're going to go over. So the first one I have here, 18 x to the 10th minus 2. So we look at this. First thing we ask, is there a greatest common factor? So we're going to look here. First thing I'm always going to look at are the two numbers. I have an 18 and I have a 2. Is there something that goes into both of those numbers nicely? And the answer is yes. I can pull out a 2. So I'm going to write a 2, and then I'm going to write 1 parentheses, because what I have left over I'm going to have in that parentheses, and I'm going to continue to look at what is in the parentheses to see, well, can I do another step here? So I pulled the 2 out, and I'm now going to also look and say, well, do I have the variable? No. I kind of jumped the gun here. That's why I should have left a little bit of space in case there was a variable there. So I look and I go, okay, well, 18 divided by 2, that's 9. I can't do anything to the variable, so I'm going to put x to the 10th, and then minus 2. So I'm going to put 2 divided by 2, that's going to be 1. Now, just to be safe, I'm going to go back to that first question of, is there a greatest common factor? Just to be sure, because if I messed up and I check again, I can see, oh wait, I have another greatest common factor, so it must not have been a greatest common factor the first time, so let me take it out again. And if that ever happened, I'm just going to multiply what I already have on the outside by the new factor that I'm pulling out. So I have a 9, I have a 1, they don't have anything in common, so I move on. So the next question, is this difference of two squares? And I'm only looking in the parentheses right now. And when I look, I have subtraction, I have two terms. The first term is 9x to the 10th. 9 is a perfect square. X to the 10th, because it's an even exponent, it's a perfect square. Remember, we know it's a perfect square if I can divide the exponent by 2. And 1 is a perfect square. So I have difference of two perfect squares here. So what I'm going to do is I'm going to rewrite my factor that's already outside. So the 2 I'm going to write down again. And now I'm going to set up my double parentheses. So I go, okay, well I know it's difference of two squares, so I know I'm going to do a plus and a minus in the parentheses. And now I'm going to start here. 9 square root of 9 is 3. So I put that in the front. It's followed by an x variable. So the x goes over there. Then I'm going to go look at the exponent of 10. I'm going to divide that by 2. 10 divided by 2 is 5. So my exponent in the parentheses is 5. So that first term in the parentheses is 3x to the 5th. Then I look at the second term. It's a 1. Square root of 1 is just 1. I put a 1 in each parentheses. And then I go back and I check each of the parentheses. Is there a greatest common factor here? Well, if we did our job up here, then no. 3 and 1. No common factor. Same over here, 3 and 1. No greatest common factor. Is this difference of two perfect squares? Well, I'm going to take a look here first. I have a plus, so it's definitely not difference in this one. So that's not difference of two squares. I'll look in this parentheses. Oh, there's a minus, so difference, two terms, getting close, but 3x to the 5th is not a perfect square, so this is not difference of two perfect squares. And since I know that they're not trinomials, because there's only 1, 2 terms here, and 1, 2 terms here, that's it. We're done. This is factored completely. Okay? So that long thing, if I multiply all that back, and I use my my FOIL, or whatever you want to call it, to the double distributive to multiply these together, and then multiply that by 2, I should be able to get back to that first 18x to the 10th minus 2. Okay? Let's take a look at this one. X to the 4th minus 14x to the 3rd plus 13x squared. So when I look at this, again, my first question, is there a greatest common factor? Again, I'm always going to look first for numbers. Well, this is a 1. As soon as I see that I have a 1, I kind of know that the numbers aren't going to work. So I move now to the variables. I have an x to the 4th here, an x to the 3rd here, and x to the 2nd here. Each of these terms has an x, so there's definitely a greatest common factor that involves x. And then I'm going to look and say, well, what's the smallest exponent of these 3? That's a 4, that's a 3, that's a 2. That's the smallest. So my greatest common factor is x squared. I set up a parentheses, and now I go back and I say, okay, well, x to the 4th divided by x to the 2nd, I'm taking 2 of those x's that are multiplying out, and we're left with x squared. The minus 14 stays. X to the 3rd, take my 2 x's that I'm multiplying by out of there, I only have 1 x left. And then here, I took the x squared totally away, so I'm left with plus 13. So now I'm going to focus on inside the parentheses because I can't do anything else with this. All right, I can't pull any more common factors out, and there's no other factoring I can do there. So I'm going to write x squared. And I look in here, I'm going to first ask, do I have any other greatest common factors? Again, if we did it right the first time, the answer should be no. No. Difference of two squares? Well, I have subtraction, but 1, 2, 3 terms. So it's not difference of two squares. So it's got to be some form of trinomial factoring. Is the leading coefficient equal to 1? Yes, it is. So I'm going to set up my double parentheses, and I'm going to put x in the front of both. I look at the last term. It's a positive number. That means the two numbers that I multiplied together have the same sign. I look to the middle term to tell me what that sign is. It's a minus, so I'm going to put a minus in both parentheses. Next I have to go and say, well, what numbers multiply out to 13 and add to 14? Well, here's where it gets nice. My only option is 1 and 13, because 13 is prime. And luckily, 1 plus 13 equals 14. Put a 1 in that parentheses, 13 in that parentheses, and I'm done. Because no more greatest common factors, no difference of two squares, and they're not trinomials. So I can't do anything else. Even if you look here, I go, oh, I got that x minus 1, but that's not x squared. So no difference of two squares. Okay? Those two were multi-steps that weren't too bad. Okay? Let's keep going though. Here, I have a trinomial, 4x squared minus 24x minus 160. So, again, I'm going to start off. Is there a greatest common factor? I have a 4 here, 24, 160. Does 4 go into all three of those things? Yes, it does. So I'm going to write down 4. Then I'm going to look. Do I have variables that repeat? X squared, x, no more x's. So x is not a common factor. And now I'm just going to start dividing by 4. This, the 4 cancels out completely. I have an x squared. Minus 24 divided by 4 is 6. Minus 160 divided by 4 is 40. Okay, so again, I'm going to double check. Do I have any greatest common factor here? No, I do not. So, difference of two squares? Well, I have difference, but again, 1, 2, I have 3 terms, so it can't be difference of two squares. Is the leading coefficient equal to 1? Yes, it is. So, I'm going to go put an x in the front of both parentheses. I look at the last term, it's a minus. Minus means opposite signs. So I'm going to put plus in the first one, minus in the second one. Because this is a negative in the middle, that means my larger of the two factors is going to go here. So I'm going to go again. This is where the screw for the wall hanging is. Wall hanging, not here. So I need two numbers that multiply out to 40, but when you subtract them, give you 6. So I'm going to go 40. I get 1 and 40, 2 and 20, 4 and 10, 10, 5 and 8, and that's it. We do our subtraction. That's 39. No good. 20 minus 2 is 18. No good. 10 minus 4 is 6. There are our numbers. The bigger number is going to wind up being negative. 10 is bigger, so 10, conveniently enough, goes in the second parentheses. 4 in the first parentheses. We double check the parentheses. Greatest common factor anywhere in here? No. How about in this one? No. Difference of two squares? This is addition, so no difference. Yes, this has subtraction. Yes, it has two terms, but neither one is a perfect square, so that's our answer. 4 times x plus 4 times x minus 10. Okay? So you see, these are kind of getting a little bit difficult, but still, you know, as long as you're paying attention to what you're doing, okay, it's a little ugly, it's a little intimidating, but I'm going to take these little steps and make it where it's a little bit nicer each time. This one, 5x to the 4th plus 35x to the 3rd minus 150x squared. That's some big numbers. Just go about the questions. Is there a greatest common factor? So again, I'm going to look at the numbers first. 5, 35, and 150. 5 goes into all of these. That ends in a 5, that ends in a 5, this ends in a 0. So 5 can go into all of them. So I'm going to write 5. I'm also going to change my pen. Then I'm going to look at my variables. I got an x to the 4th, x to the 3rd, x squared. They all have an x. So I definitely have x as a greatest common factor. Bless you. My wife coughed and sneezed. Gotta be nice. Bless you. Look which one has the smallest exponent, and it would be here, the 2. So put the 2 there. Big parentheses. Divide everything. This divided by 5 is just going to be the x to the 4th, but x to the 4th divided by x to the squared, x to the 2nd, x to the squared. Blah, 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 blah. Is x to the 2nd. Divide this. 35 divided by 5 is 7. X to the 3rd divided by x to the 2nd is x. Minus 150 divided by 5. 30. X squared divided by x squared goes bye-bye. So we're left within the parentheses, x squared plus 7x minus 30. So again, is there a greatest common factor here? Nope. 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 We're done. Because we did our job in the first place. We found the greatest common factor right away. Is this difference of two squares? No. Because again, yeah, we have subtraction, but 1, 2, 3 terms. Is the leading coefficient 1? Yes, it is. So that just makes things a little easier. So, I'm going to rewrite this. 5x squared, 2 parentheses. Alright, the x is going to go in the front of both parentheses. The last term is negative, so that means that we have a positive times a negative. So plus, minus, and this shows that the positive number is going to be, the larger number is going to be positive. Okay? So I need the factors of 30 that when I subtract them, give me 7. So we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. 30 minus 1, 29. Doesn't work. 15 minus 2 is 13. Doesn't work. 10 minus 3 is 7. So our factors are 3 and 10. 10 is bigger, so 10 is going to be positive. So I put it in the first parentheses. And the 3 goes in the second parentheses. Just to be sure, do we have any greatest common factors in this parentheses? No, we do not. How about in this one? No, we do not, because we already did the work. Is this difference of 2 squares? Nope. Is this difference of 2 squares? Nope. At that point, we're done. 5x squared times x plus 10 times x minus 3. That's our factored completely answer. Last two. Alright? Now, one of the things I wanted to do, and then I wrote them all down, and then I started this, and I was like, oh shoot, I totally forgot about that. One of the things I want to point out is, if we do have a difference of 2 squares, the x value, the x doesn't always have to be at the front. So, I'm going to give you a hint right away. This is a difference of 2 squares. I could have had it the other way around, 16 minus x to the fourth. And that would have still been difference of 2 squares. The x value, the x variable does not always have to be on the left side of the equation, or the left side of the expression. It can be on the right side, and you just have to deal with it the way you do. You just ask the questions. Do I have difference? Do I have subtraction? Are there 2 terms? And are they perfect squares? The order of those 2 things only matters when you factor them and make sure that you don't switch things around. Remember, subtraction is not commutative. I can't switch the order of the 2 things and have the same answer. It's not, doesn't work that way. Side note. Okay, so there we go. Alright, so x to the fourth minus 16. Do we have greatest common factor? No, we don't. This is the first one we didn't have greatest common factor. Cool, so we move on to difference of 2 squares. Do I have difference? I already said this. Do I have difference? Yes, I do. Are there 2 terms? Yes, there are. Are they both perfect squares? This is a variable with a positive even exponent, so I can divide it by 2, so it is a perfect square. 16 is a perfect square. So I'm going to set up my double parentheses, plus in one, minus in the other. I look, x term in the front of both. 4 divided by 2 is 2, so I'm going to put that there and there. Square root of 16 is 4. So I put that in both. I'm going to fix this again. Now I continue to go back and I ask my questions. Do I have greatest common factor? No. No. Are either of these difference of 2 squares? Well, that's plus, so it's definitely not difference. So I'm going to write that down again. X squared plus 4. I look at the second parentheses. X squared minus 4. There's subtraction, so there's difference. There's 2 terms, and they're perfect squares. So I can factor this using difference of 2 squares again. So I'm going to go do it. Set up my parentheses. Okay? Plus in one, minus in the other. That's an x. Put that in the front. 2 divided by 2 is 1. So I don't necessarily have to put an exponent on these. Square root of 4 is 2. Ask the questions again. I know it seems ridiculous, but you got to ask the questions over and over to really be sure you factored completely. you stop too early and you're taking a test, you're going to lose points. We already said this is as good as it's going to get. No greatest common factor, no greatest common factor. This is not difference, so it can't be difference of two squares. This has difference, but these aren't perfect squares. So that's it. This long thing is our answer. Okay? Last one. 125x to the 11th minus 20x. Guys, these big numbers. Man. Alright. As always, do we have a greatest common factor? I got 125. I've got 20. Well, 20 doesn't go into 125. Does 10? No. Does 5? Ha ha ha! 5 does. So 5 goes into both 125 and 20. And then I look at my variables. I got x to the 11th and I got x. So both terms have an x. And this has the smallest exponent because it's 1. So I don't have to do anything. So I set up my parentheses. 125 divided by 5 is 25. X to the 11th divided by x, I'm really just taking away 1 from my exponent. So I have x to the 10th minus 20 divided by 5 is 4, and that x goes bye-bye. And look again, do we have greatest common factor here? 25 and 4 don't have anything in common, and we only have an x term on the first term. So no difference, so no greatest common factors. Alright, do we have difference of two squares? Well, subtraction, two terms, 25 is a perfect square. The exponent on the variable is an even number. It can be divided by 2, so it is a perfect square, and 4 is a perfect square. So, difference of two squares. Right, 5x down again. Remember, when you're factoring, don't just make, like if something is a factor, don't just make it disappear. Okay? So, I make two parentheses. Okay? And now I go, okay, well, square root of 25, 5. Put that in both. I got my x term. 10 divided by 2 is 5, so my exponent on my x term is 5. Plus in one, minus in the other. Square root of 4 is 2. Ask the questions. Do we have greatest common factor? No. Do we have difference of two squares? No. Do we have, we have a leading coefficient, but we don't really have anything else. We can't do trinomial factoring because they're not trinomials. So we're done. So this is our factored answer. Yay! Now, I hope this was helpful. If it was, please like and subscribe. It helps other people find the channel and find the videos so that they can get help and help improve their math skills. I am Mr. Oaks. Keep learning. Bye.